NEC 240.40 addresses the placement of overcurrent protection devices, specifically within panel boards. A key requirement of this section is that these devices must be readily accessible. However, the National Electrical Code, or NEC, itself does not provide a precise definition of what constitutes readily accessible. The interpretation of this term is crucial in various electrical installations. In the situation described, the fuses are housed within a box that is secured with tamper-proof screws. These screws necessitate the use of specific tools for removal, effectively restricting access to qualified personnel who possess these tools and the necessary expertise. Furthermore, the fuse holder has been designed to allow for lockout during servicing, achieved by disconnecting and locking off the breaker that feeds the riser. Considering these factors, the question arises whether the described fuse arrangement meets the requirement of being readily accessible, as outlined in NEC 240.40. Several arguments can be made to support the assertion that the fuses, in their current configuration, are indeed readily accessible. Firstly, access is limited to qualified personnel. These individuals have the training, knowledge, and tools necessary to safely and effectively work with electrical equipment. Secondly, the tamper-proof screws deter unauthorized access by unqualified individuals, thus enhancing safety. Thirdly, the ability to lock off the fuse for servicing provides an additional layer of safety during maintenance or repair work. However, other perspectives may suggest that the need for specialized tools to access the fuses could be interpreted as hindering accessibility, especially in emergency situations where immediate action might be required. Some may argue that readily accessible should mean accessible without the need for tools or with minimal effort. Ultimately, the interpretation of readily accessible can vary depending on the specific context and the judgment of the authority having jurisdiction, or OJ. Given the ambiguity surrounding the interpretation of NEC 240.40, it is advisable to seek clarification from the local AHJ or a qualified electrical inspector. They can assess the specific installation and provide a definitive ruling based on their understanding of the code and local regulations. In addition to consulting with the AHJ, it is also prudent to consult with a qualified electrician. Their expertise and experience can provide valuable insights into the practical implications of the fuse placement and the need for a local disconnect. They can assess the overall electrical system and determine whether the current configuration meets all applicable safety standards and best practices. Regarding the need for a local disconnect for each fuse, several factors should be considered. Firstly, the purpose of a local disconnect is to provide a means of safely isolating the circuit for maintenance or repair. Secondly, if the fuse can be locked off at the breaker serving the riser, this may provide sufficient isolation. Thirdly, the need for a local disconnect may depend on the specific requirements of the equipment being served by the circuit. When evaluating the necessity of a local disconnect, consider the potential hazards associated with working on the circuit without one. Firstly, the risk of electrical shock or arc flash should be assessed. Secondly, the complexity of the equipment being served and the potential for accidental energization should be taken into account. Thirdly, a frequency of maintenance or repair work on the circuit should be considered. If the risks are deemed significant, a local disconnect may be warranted to enhance safety. In conclusion, the interpretation of NEC 240.40 regarding the accessibility of overcurrent protection devices can be complex and subjective. While the tamper-proof box and lockout capability provide a degree of safety and control, the need for specialized tools to access the fuses may raise concerns about accessibility. Consulting with the AHJ and a qualified electrician is essential to ensure compliance with the code and to determine the most appropriate solution for the specific installation. The decision of whether or not to install a local disconnect should be based on a thorough assessment of the risks and benefits, taking into account the specific requirements of the equipment being served and the overall safety of the electrical system. The intent of the NEC is to provide a safe electrical installation. The NEC is not intended as a design specification. The NEC provides minimum requirements for electrical safety. It is up to the design engineer to provide a complete electrical design that meets the needs of the installation. NEC 110.3 These states that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. This means that if the equipment is listed, it must be installed and used in accordance with the manufacturer's instructions. NEC 110.12 states that electrical equipment shall be installed in a neat and workmanlike manner. This means that the installation should be done in a way that is both safe and aesthetically pleasing. NEC 210.8 provides requirements for ground fault circuit interrupter protection for personnel. Ground fault circuit interrupter protection is required for receptacles in certain locations such as bathrooms, kitchens, and outdoors. NEC 215.9 provides requirements for ground fault protection of equipment. Ground fault protection of equipment is required for certain equipment, such as motors and transformers. NEC 225.30 specifies the number of supplies. Number of supplies. Where a building or other structure is supplied by more than one feeder or branch circuit, one disconnecting means shall be provided for each feeder or branch circuit at or near the point of entrance to the building or other structure. NEC 230.70 provides requirements for the location of the service disconnecting means. The service disconnecting means must be located at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. NEC 240.2 states that overcurrent protection shall be provided in each ungrounded conductor of a circuit. This means that each ungrounded conductor must be protected by a fuse or circuit breaker. NEC 240.24 specifies the location in circuit of overcurrent protection. Overcurrent protection shall be located at the point where the conductors receive their supply. NEC 250.4 outlines the general requirements for grounding and bonding. Grounding and bonding are essential for electrical safety. NEC 300.11 dictates securing and supporting wiring. Wiring should be properly secured and supported to prevent damage and maintain safety. NEC 310.16 provides ampacity tables for conductors. These tables list the allowable ampacities for different types of conductors under various conditions. NEC 314 covers outlet boxes, conduit bodies, and handhole enclosures. This article provides requirements for the installation of these components. NEC 408 covers switchboards and panel boards. This article provides requirements for the construction and installation of switchboards and panel boards. NEC 430 covers motors, motor circuits, and controllers. This article provides requirements for the protection and control of motors. NEC 440 covers air conditioning and refrigerating equipment. This article provides requirements for the installation of air conditioning and refrigerating equipment. NEC 450 covers transformers. This article provides requirements for the installation of transformers. NEC 500 through 516 provide requirements for hazardous classified locations. These articles provide requirements for the installation of electrical equipment in areas where flammable gases, vapors, or dust may be present. First, ensure compliance with NEC 110.3. B, which mandates that listed or labeled equipment must be installed and used according to the manufacturer's instructions. This is paramount for safety and proper operation. Second, adhere to NEC 110.12, which requires that all electrical equipment be installed in a neat and workmanlike manner. This ensures both safety and aesthetic appeal. Third, follow NEC 210.8 for ground fault circuit interrupter, or GFCI, protection, which is essential in areas like bathrooms, kitchens, and outdoor locations to protect personnel from electrical shock. Fourth, implement NEC 215.9 for ground fault protection of equipment, which safeguards motors and transformers from ground faults. Fifth, comply with NEC 225.30, which states that each feeder or branch circuit supplying a building must have a disconnecting means at the point of entry. Sixth, ensure that the service disconnecting means is readily accessible as per NEC 230.70, either outside the building or inside near the service conductor entry point. Seventh, provide overcurrent protection in each ungrounded conductor as required by NEC 240.2, using fuses or circuit breakers to protect against overloads and short circuits. 8. Locate overcurrent protection at the point where conductors receive their supply according to NEC 240.40. 9. Adhere to the general requirements for grounding and bonding outlined in NEC 250.40, which are crucial for electrical safety. 10th. Secure and support wiring as dictated by NEC 300.11 to prevent damage and maintain safety. 11th. Use the ampacity tables in NEC 310.16 to determine the appropriate conductor sizes for different conditions. 12th. Follow the guidelines in NEC 314 for installing outlet boxes, conduit bodies, and handhole enclosures. 13th. Comply with NEC 408 for switchboards and panel boards, ensuring the proper construction and installation. 14th. Implement NEC 430 for motors, motor circuits, and controllers, providing adequate protection and control. 15th. Adhere to NEC 440 for air conditioning and refrigerating equipment installations. 16th. Follow NEC 450 for transformer installations. 17th. Comply with NEC 500 through 516 for installations in hazardous locations. The interpretation of NEC 240.40 regarding the accessibility of overcurrent protection devices depends on various factors, including the specific installation and the judgment of the authority having jurisdiction. While the tamper-proof box and lockout capability provide a degree of safety and control, the need for specialized tools to access the fuses may raise concerns about accessibility. Consulting with the AHA and a qualified electrician is essential to ensure compliance with the code and to determine the most appropriate solution for the specific installation. The decision of whether or not to install a local disconnect should be based on a thorough assessment of the risks and benefits, taking into account the specific requirements of the equipment being served and the overall safety of the electrical system.